are talking today officially about graphing quadratics. Now, if this is your first time with these notes and you are watching this video without having taken notes from me, I'm going to ask you to hit pause so that you can write these down. These are the steps that you need to properly graph an equation in standard form. And remember, standard form looks like this. Ax squared plus bx plus c. So you're going to find the axis of symmetry, which is the x value of your vertex, by using the equation negative b over 2a. You're going to plug your x value into the equation, find the y value, and you have your vertex. You're going to create a table using two values to the right of the vertex, plugging them in to your equation, and then you're going to plot the points and reflect them across the axis of symmetry. So like I said, if you are taking notes on this for the first time, go ahead and pause so that you can write this down. All right. I have the equation y equals x squared minus 6x plus 13. So first thing I'm going to do is I'm going to determine my axis of symmetry using the equation x equals negative b over 2a. So I know that a is 1, b is negative 6, c is 13. So if I'm taking negative b over 2a, that's going to give me negative 6. So I have a negative in the equation and in the value, over 2 times 1, which this is going to become a positive 6, over 2, which is 3. So I know that my axis of symmetry is 3. So somewhere along this line, a vertex will fall. Step 2, I'm going to take this 3, I'm going to plug it in for x in my equation. So I'm going to have y equals 3 squared minus 6 times 3 plus 13. That's going to give me 3 squared is 9 minus 18 plus 13. So 9 minus 18, that's negative 9, plus 13 is 4. So my vertex is 3, 4. So on that axis of symmetry, here's my vertex. Now I'm going to pick 2 points to the right of my vertex, and I'm going to plug them in. So I'm going to pick the values 4 and 5. I already know 3. So I plug in 4 into my equation. I'm going to have 4 squared minus 6 times 4 plus 13. That is 16 minus 24, which is negative 8, plus 13, which is 5. So I'm going to have a point at 4, 5, and I'm also going to plug in the value 5. So I'm going to have 5 squared minus 6 times 5 plus 13. That gives me 25 minus 30, which is negative 5, plus 13, which is 8. So the next value is 5, 8. So that's this one. So I have 3 points plotted, and I have my axis of symmetry. Remember, your axis of symmetry cuts your shape in half. So I can actually plot 2 more points, knowing that this line is the axis of symmetry. So this point here is 1 away from my axis of symmetry, so I'm going to plot another point on the other side. This point here is 2 points, 1 and 2, away from my axis of symmetry, so I'm going to go 2 points away from my axis of symmetry. So my parabola looks like this. It makes sense that it opens this way because if you remember, your A value tells you which way the parabola opens. So if A is positive, that means it opens up. A is negative, that means it opens down. Make a little note by that, keep that in mind. Let's try another thing. I have the equation negative x squared minus 2x minus 4. First step, I need to find my axis of symmetry using the equation negative b over 2a. So I know that a is negative 1, b is negative 2, c is negative 4. So I'm going to take negative 2 over 2 times negative 1. So it's 2 over negative 2, which is negative 1. So somewhere along this line, I have my vertex. So I'm going to plug in that negative 1 into my equation. Be really careful about that negative. So I have y equals negative 1 squared minus 2 times negative 1 minus 4. This is going to become a 1, but that negative is out in front of it. So it's actually going to be a negative 1 plus 2 minus 4. That gives me a negative 3. So my vertex, negative 1, negative 3. I'm going to pick 2 points to the right of my vertex. So since my x value is negative 1, I'm going to go 0 and 1. So I have negative 1, negative 3. I'm going to go 0 and 1. So 0 is easy. 0 squared plus minus 2 times 0 minus 4. That's negative 4. One is negative 1 squared minus 2 times 1 minus 4. That's negative 1 minus 2, negative 3. This is negative 7. So I have 2 points, one at 0. Here's my vertex. And I have one at 0, negative 4, and one at 1, negative 7. And remember, I can reflect these points across my axis of symmetry to get 2 additional points. So this is 1 away, so I have another one here. This is 2 away, 2 here. So my parabola this time looks like this. It makes sense that it's opening down like this because A is negative. Now, if you're feeling comfortable with the steps, I want you to try these on your own. I'm going to kind of go through them, but less specifically. So, first step, axis of symmetry. X equals negative b, so negative 12 over 2 times 2. 4, which is negative 3. Somewhere along the equation, x equals negative 3, my vertex occurs. So I'm going to plug in that negative 3. Let's see. 18 minus 36, so negative 18, plus 21 is 3. So my vertex falls at negative 3, positive 3. And I'm going to pick 2 values to the right. So I'm going to pick -2, and -1. So plug in -2, I'm going to get 2 times -2 squared plus 12 times -2 is 21. That's going to give me 8 minus 24, so -16, plus 21 plus 5. So -2, 5. And then if I'm going to do -1 over here, that equals 2 times -1 squared plus 12 times -1 plus 21. That gives me 2 minus 12, so -10 plus 21 is 11. So I'm going to plot those points at -2, 5, and -1, 11. So right here. And I'm going to tuck those points across. This one's 2 away. This one is 1 away. So my parabola looks like this. Go ahead and try the last one yourself. I'm not going to talk. I'm just going to write answers down, but I do need to erase this. If you're still writing, hit pause. Okay, last thing. We've got a word problem here. So we're visiting the Leaning Tower of Pisa. All this is happening. His sunglasses fell off. So the height of the sunglasses as they're falling, so in air, is given by the equation negative 5x squared plus 50, where x is time in seconds. We need to graph the equation. So I'm actually going to rewrite this equation as negative 5x squared plus 0x plus 50. Because I want that term, because I need to use that to find my axis of symmetry. So I'm going to use my negative b over 2a. So that's negative 0 over 2 times negative 5, which we know is 0. So if I have this graph, I know that somewhere along the x-axis, my vertex will occur. I'm going to plug that in. Y equals negative 5 times 0 squared plus 0 times 0 plus 50. It means my vertex is 0, 50. So I'm going to go five. So my vertex is over here. And I'm going to plug in 1 and 2. So negative 5 times 1 squared plus 50 is 45. Negative 5 times 2 squared plus 50 is 30. So I have, go by. So 1 is 45, 2 is 30, and if I were to reflect this across, it's going to be something like this. All right, so I've graphed my equation. Now we have to talk about domain and range. So usually in quadratic, my domain is all real numbers. But since this is a real world problem and this is time, you should know about time that there's no such thing as negative time. You can't have negative seconds. So actually, this whole part of the graph is obsolete. It doesn't exist because it has to be positive in order for it to work. So my domain this time is not all real numbers. It's going to be x is greater than or equal to 0. And actually, it stops somewhere between 3 and 5. It's the ground. And there's not negative ground to talk about here, unless there's a pool. So it's actually going to be less than or equal to like 3.5. And my range is normal. My range has to be less than or equal to 50. That's my vertex. But it also has to be greater than or equal to 0 because there are no y values greater than or equal to 0. And the last question is asking when this hits the ground. It hits the ground somewhere between 3 and 5 or 3 and 4 seconds. All right, you got some time to work on homework.